Okay, so I'm just going to go over the notes from today because we had several people absent today for pre-calc. Solving an absolute value equation. You've done this before, so most of what we go over here is going to be review. I'll try to highlight what isn't here as we go through. So to solve an absolute value equation, first thing you want to make sure is the absolute value portion alone. That is this guy by himself? And if that's the case, then we're going to go ahead and write two statements. We're going to write 2x minus 4 equals 10. Notice there's no absolute value sign. And we're going to write another one, 2x minus 4 equals negative 10. And where that second part, notice the difference, we changed the ending to a negative 10. And now we'll just use our algebra skills to solve for x. So we'll add 4. 2x is equal to 14. Divide by 2. And x is 7. And on the other side, we'll add 4, and we'll get 2x is equal to negative 6, and we'll divide by 2, and we'll find x is negative 3. Now, the downside to this is that sometimes in solving absolute value equations, you create answers that actually aren't answers. So we do have to check each one of these, and so to do that, I'm going to put 7 in here and just talk my way through it. 2 times 7 is 14. 14 minus 4 is 10. The absolute value of 10 is 10. Okay, and then take negative 3, put that in here. 2 times negative 3 is negative 6. Negative 6 minus 4 is negative 10, but the absolute value of negative 10 is 10. So it does prove that, or does check out that both negative 3 and 7 are solutions here. We also talked in class today that we could head to our calculator to check, and we could say y equals absolute value of 2x minus 4. That goes in y1, and in y2 you might put the 10. And you're going to get a v and a straight line, and the solution of that is where the v meets the straight line. And so what you'll find probably is that this side is negative 3, and that yes, they intersect here over at a place called 7. So that's another option if you'd like to do that. Remember, to find out where they intersect, you go to second trace intersect and run through the questions of first curve, second curve, and guess like we did in chapter 1. If you have questions on the checking in the next couple of days, just speak up in class and we'll get you through that. But it is imperative that you check these somehow, because sometimes the answers you get from algebra aren't actually answers to the problems. Okay, I want you to notice the difference to this example. The difference to this example is that we are facing an absolute value inequality instead of an equation. So when we write our two statements, the first part kind of looks the same. We're going to say 2x minus 6 is less than or equal to 8, and we're going to say 2x minus 6, but we have to change the symbol of inequality when we change the ending on these, so now it's greater than or equal to, and we change the 8 to a negative 8. So when you change the ending, it's more than just the number. You have to also change the symbol of inequality on the second one. Okay, and now we will just solve both of these. We will add 6. We will get 2x is less than or equal to 14. We'll divide by 2. We'll get x is less than or equal to 7. Over here on this one, we'll add 6. We'll get 2x is greater than or equal to negative 2. We'll divide by 2. We'll get x is greater than or equal to negative 1. It's worth noting here that remember that if you divide by a negative, you would want to flip that symbol of inequality, but we didn't have that here. But if you ever have to divide by a negative, you flip that the other direction. We probably remember that. And now, what we will do is we will think about having a number line. Negative 1 would be left of positive 7. And now there are 3 sections created here by the numbers negative 1 and 7 on the number line. What we want to do is we want to talk about picking a number in each section that would be easy to do math with. So I would say pick a number that's less than negative 1. I could probably do easy math with negative 10. Pick a number that's between negative 1 and 7. Definitely want to do math with 0. It's easy math. And pick a number that's greater than 7, and I'm going to say positive 10. Now let's talk our way out of each one of these things. If I put negative 10 in here, 2 times negative 10 is negative 20. Negative 20 minus 6 is negative 26. The absolute value of negative 26 is positive 26, and 26 is not less than or equal to 8. So what we learned by that is that this area, all of that entire area, is not a solution to this equation. Try 0. Well, if we do the same thing for 0 here, 2 times 0 is 0. 0 minus 6 is negative 6, but the absolute value of negative 6 is positive 6, which is less than or equal to 8. So therefore 0 is a solution, and we'll just say keep that. And 10. One last check here with 10. And 2 times 10 is 20. 20 minus 6 is 14. The absolute value of 14 is 14, and 14 is not less than or equal to 8. So what we learn is this is not the set of answers. So now what we know is that the interval of answers is from negative 1 to 7. And we would want to include, because of the equal sign, include the ends. So we would want to bracket and bracket. And there is our interval of answers to this absolute value inequality. Okay, this one will be real fast. We want to set up the first equation, x minus 5 is greater than 2. And I would say or x minus 5 is less than negative 2. And so what we will do is we will solve by adding 5 and get x is greater than 7. Add 5 and get x is less than 3. And now again, make a number line. Think of 3 is less than 7 there. We've created 3 areas, and we're going to check a number in each area to see which area is the solution. So 3 and on down would be a good number to be would be 0. 5 is a pretty easy number to do math with in between, and 10 is an easy number to do math with above. So let's work that out by plugging 0 in here. 0 minus 5 is negative 5. The absolute value of negative 5 is 5, and 5 is greater than 2. So that is true. Let's do the next one here. Let's do 5. 5 minus 5 is 0. The absolute value of 0 is 0, and 0 is greater than 2 is not true. So we do not want to use any number from 3 to 7. And let's do one more with 10. 10 minus 5 is 5. The absolute value of 5 is 5, and 5 is greater than 2 is true. So we have the solutions to this absolute value inequality on the ends. So we would probably say, reading from left to right, that negative infinity until 3, and we do not want to, that was a mistake, we do not want to include 3 because there is no equal sign here. And we would union this together with 7 to infinity. And so there represents all the solutions to this absolute value inequality. Okay, we have one more, and this one looks a little different because we've got absolute value on both sides. That is not a big deal, though. It's actually convenient in that we're going to write this just like the very first one I did. X plus 4 equals 2x minus 6. No change whatsoever, just don't put the absolute value in there. And on the second one, we need to change the ending. So x plus 4 is equal to, and to change the ending 2x minus 6, we have to change them both. So it's negative 2x and plus 6. And now we'll work these out. We'll subtract x. Add 6. So x is 10. And over here, subtract x. Subtract 6. Divide by negative 3. X looks to be 2/3. Okay, let's check both of those out. If we put 10 in, we would end up with 14 on this side. And if we put 10 on this side, we'd end up with 14 on this side. And the absolute value of 14 and the absolute value of 14 are equal, so that checks, that's a solution. If we put 2/3, we would have 4 and 2/3 on this side. And over here, we would have 4/3 minus 6, which would be negative, let's see, 4 thirds minus 6. 6 as thirds would be 18 thirds. 4 thirds minus 18 thirds would be negative 14 thirds, which would be 4 and 2 thirds. So the absolute value of negative 14 thirds would be 4 and 2 thirds. So they are equal at 4 and 2 thirds. Therefore, that checks out as well. And they're both solutions. Just noting that, how do we get started on this one? When you've got absolute value on both sides like that, basically just write the first time without any changes whatsoever except no absolute value. And the second time you want to change both terms. If there's 7 terms, you change all 7. But that is that one. Okay, we're going to wrap this up with a few special cases. Special case number 1 looks like problem number 1 we started out with. So one might just think absolute value of x plus 1 equals negative 3, x plus 1 equals negative 3, and x plus 1 equals positive 3. And if we subtract 1, subtract 1, and subtract 1, and subtract 1, we get x equals negative 4, and we get x equals 2. So if you were in a hurry here and didn't think it was important to check your work, you'd think the answers were negative 4 and 2. But if you do check your work, you find out that isn't the case. Because negative 4 plus 1 is negative 3, the absolute value of negative 3 is positive 3, and positive 3 does not equal negative 3, so this is not a solution. The other one here, positive 2, let's check it. 2 plus 1 is 3, the absolute value of 3 is 3, not negative 3, and this one too fails the check, so there are no solutions. In fact, I knew that was going to be the case when I saw this, because the absolute value of anything will be a positive value, and it will never be a negative value. So at the beginning, I actually knew there were no solutions to this one when I first looked at it. Okay, we're going to take about 2.5 seconds on this one because, again, even though we have an inequality here, the absolute value is always a positive value, and a positive value is never going to be less than or equal to a negative value. So what are the solutions to this one? There are no solutions. Okay, so again, about 2.5 seconds on this one, and we'll be out of here, because when is the absolute value, that is a positive answer, always greater than or equal to a negative answer? It always is. So the answer here is for any x, negative infinity to positive infinity, the left side will be greater than the right side.